This video is absolutely chock full of fatherly advice and good network design guidelines, which is a fun way of saying there are no labs in this video. Actually, there are a couple, but we're going to do them on the board, and you will see why here in a moment. And still some good stuff here for real-world networking. Just a couple of guidelines to begin with when it comes to designing our EIGRP networks, and a couple things here we've already gone over. First off, you really do want to invest that time to set up your IP address allocation scheme before deploying them. You don't want to just measure twice and configure once. You want to measure several times. As we've seen with route summarization, we know how powerful that can be, and it can take some of the load off of our hardware. So we want to maximize our opportunities wherever possible for manual route summarization on one side of the router, so to speak. Speaking of that, if you can avoid discontiguous networks, wonderful. Please, as we saw, keep EIGRP's auto-summarization behavior in mind when you can't avoid them. We know that the hub routers in any hub and spoke network are always going to have the larger workload of any of them, so we want to make sure those routers have the CPU and memory resources that they need. And there are a few extra details to attend to when we're allocating our bandwidth over an NBMA network. Now, the typical serial interface is going to have multiple virtual circuits, the VCs, and the calculation for the bandwidth command varies according to the type of interface used on the hub and, of course, the committed information rate, the CIR, that's assigned to each circuit. And a couple of good questions, to answer before you start configuring. And I know you can see these, and I'm going to read them as well, but I know planning sucks. Don't tell anybody I said that. But it does. You just think, you're right, I forgot what's like, oh, let's just get to work. And I've worked with guys like that, and I'm not going to name any names, but it really just leads to trouble. And I don't care. It could be Cisco. It could be anything. I mean, one of the longest weeks of my life was after an email deployment of all things. And the guy just, he's a bright guy, but he didn't do the planning. And I know sitting down at the table and writing it all out is boring, but boring is better than fixing, I like to say. So, just a couple questions to answer before you sit down and start hammering out that config. What is your current CIR? What is the committed information rate for the company you're at, the network you're on? What are the current bandwidth values on the interfaces? Are there special requests and, probably more importantly, policies that need to be taken into consideration? Do we have some bandwidth maximum and minimums that have been guaranteed? Do we have stub routing potential, that kind of thing? Now we're going to take a look at a couple of different scenarios on the board and see how they affect the bandwidth setting. And the first one, we have no sub interfaces, and all of our VCs are using the same CIR, and the hub is using the physical interface. Well, with no sub interfaces in use, and the CIR the same for every virtual circuit, you know what to do here. Add the CIRs, you have your bandwidth value. And that ensures that none of the circuits are overloaded, which could happen if we left bandwidth at the default of 1544, assuming a T1 line. And this is all you do. It's right under the interface, bandwidth. Just watch that because it's in kilobits, and you don't want to enter it as if it's in another kind of bit. Now, this situation's a little different. We don't have sub-interfaces yet, but our VCs are using different committed information rates. Our hub is using the physical interface. That one could be a little bit tricky. Well, in this situation, what Cisco says you can do is take the lowest CIR and multiply it by the number of virtual circuits to obtain the optimal bandwidth setting. It's not just my opinion that this is not the recommended solution. Cisco will even tell you that if you go out and look at some of their PDFs, some of their white papers on this situation and on this command, it'll tell you, hey, you can do this. It's not the best, but you can. And the problem here, of course, is that with bandwidth 168 here, you've got one channel you could be overflowing, and then the other two aren't able to go to capacity because they would be cut back. And that's why a much better solution is creating point-to-point interfaces and assigning an individual bandwidth value to each CIR. I love showing this because anytime I use point-to-point interfaces in a lab, especially in the CCNA lab, even if I say several times, okay, now this isn't necessarily real world, but it's a good example, And people will just say, and it's a good question, well, when would I use point-to-point interfaces? Well, this is one situation where you could certainly do that because you have different CIRs on your 3 different VCs, and instead of using Cisco's admittedly less than recommended solution, you could do this instead. And you're just dividing dividing the interface into sub-interfaces. And it works the same whether you have one number after serial or a 3. You've got to make it a point-to-point or a multi-point sub-interface. Then you put the IP addressing on and then the individual bandwidth settings, and you are good to go. Now, speaking of multi-point sub-interfaces, what if we had a single multi-point sub-interface instead of 3 point-to-pointers? What if we had something like this, where the hub router is now using a single multi-point sub-interface? Well, what you can do here is add up the CIR values to get the correct bandwidth value for the sub-interface. That's all you would do. So just add 512, 256, and 56. It would be tempting to do that for the first thing we looked at, where you had the hub using a physical interface and the 3 different CIRs. But again, Cisco recommends that you take the lowest value and multiply it by the number of VCs in that situation. Here, with a multi-point sub-interface, you can add those 3 values and you'd be okay. Now, let's shift our focus back to EIGRP a little bit. EIGRP's default bandwidth usage is 50% of the interface's bandwidth as set by the bandwidth command. Okay? So to change that default, you use the IP bandwidth % EIGRP command. And of course you know that we got to use the AS number in there somewhere. Well, according to this, I can set the maximum bandwidth percentage that EIGRP may use in a range from 1 to 999,999. So I could set the interface to allow EIGRP to use 999,999% of the available bandwidth. Are you kidding me? Really? I can automatically create bandwidth just by using this super magical command. And you know that's not how any of this works. That's not how this works. That's not how any of this works. But it does seem odd, you have to admit, that we could take a command like this and set the maximum bandwidth percentage to, say, 300% and not get an error. Well, how in the world can I do that? I did it right here. You know, IP bandwidth % EIGRP 100-300. Really good idea to know that the first number there is not a percentage. It's actually the AS number. But that last value, maximum bandwidth percentage that EIGRP may use. Well, is this a bug? You know, well, actually it's not. The actual physical speed of the interface can exceed the logical setting. And we tend to forget that once in a while. We could take an interface with a 512K capacity, configure it with bandwidth 56, and if we then wanted the line to allow EIGRP to use 168K of the available bandwidth, we would then set the bandwidth percent value to 300. That allows 300% of 56K to EIGRP, which is 168K. It sounds a little goofy, but I've seen where I've actually used that command myself in a production network. It worked really well. You just have to watch your syntax. Watch your syntax, my friends, because the first number is the EIGRP AS and the second number is the bandwidth percentage. So some good stuff here and some good real-world scenarios. I know that when you're looking at just diagrams on the board, it's not as exciting as actually working through a lab. But you could see with the different types of interfaces, I just wanted to give you a picture of each one of those. Now, coming up in the next video is maybe one of the best real-world pieces of advice. I don't even say piece of advice. It's not a piece of advice. It's something that will drive you crazy if you don't know about it. I'm going to give you the theory of something first, and then we're going to see it in action. And there's a little something you should know about this particular command with iOS 15. That's more real world and exam prep, but we need to know it. And I will tell you all about it in the next video. See you there.